You're running a car detailing shop. Before the day begins, you decide how many basic, comprehensive, and premium detailing jobs to schedule. The challenge is that not every employee can perform every job. Junior detailers can only handle basic work, while your most experienced detailers can take on anything. How many of each type of job should you book? Do you have the right mix of staff to support that work? And what happens when demand shifts towards more complex services? There's a model for that.
Welcome to Model Monday, a series where we break down scenarios in different industries, organizations, and departments, and explain how you can build a simulation of them in Process Playground. Let's model it.
We'll start by creating different items, which will represent different types of jobs our shop can do. The first one will be exterior wash. Then we'll create another item called interior cleaning. Next, we'll create leather cleaning and conditioning, then paint correction, and finally, stain removal. Once we've created all of our jobs, we're going to add a queue, and we'll rename this schedule. You can use a queue block to create a single batch of items at the beginning of the simulation. Now, let's add our items individually to set up our schedule for the day. We'll start with turning off Allow All Items, and we'll add exterior washes. Using initial on hand, we'll say we'll have 6 scheduled. We'll also have 6 interior cleaning jobs. Then we'll add our leather job and have 4 of those, 6 paint corrections, and finally for stain removal, we'll have 3. How long is it going to take to get all of this work done? Well, that depends on how long each of these take. So let's add an activity block at the top here, and we'll call it Basic Services. We will have 3 levels of detailers working in the shop, but all 3 of them can work on basic services at the same time. So we'll set the number of servers here to 3. Only exterior wash and interior cleaning are considered basic services. So we'll turn off Allow All Items, then we'll add exterior wash, and this will be a triangular distribution with a minimum of 20 minutes, a mode of 30 minutes, and a maximum of 40 minutes. Then we'll add our interior cleaning, and that's going to be triangular with a minimum of 20, a mode of 45, and a max of 60. The next level up is our comprehensive services. Only detailers and senior detailers can work at this level. So we're going to have a maximum of 2 servers working on this activity at a time. We'll turn off Allow All Items again, and we'll add leather cleaning and conditioning, which is triangular and ranges between 20 and 75 minutes with a mode of 60 minutes. We'll also add paint correction, which is triangular between 30, 40, and 75. And that completes our comprehensive services. And then finally, we'll have premium services. Since only our senior detailer can work on these services, we will say we only have 1 server available. We consider stain removal as our premium service, and it's triangular with a minimum of 12, a mode of 25, and a max of 40. Once we've completed our tasks, they will go into a queue block, which we'll name Stop Timer. We'll add that timer in a second. And let's connect all these blocks up back to this queue here. Right after this block, we'll add the exit block. Rather than just allowing all items, we're actually going to add each individual item to this block. This allows us to look at the statistics of each item type individually after the simulation is run. Now, for this queue block we named Stop Timer, we're actually going to add the timer block. This will store the time for each individual item to go between a segment of our process. We're going to add our Basic Services block to the start and our Stop Timer block to the stop. We'll also add our Comprehensive and Premium Services blocks. When we close out, you'll see the labels appear underneath the relevant blocks. They note that the timer on an item starts when it enters a particular activity block and then stops once it exits the timer block. So the timer will capture the time in the activity plus the time in the queue. And since the queue is connected to an exit, the item will move immediately from queue to exit, so the real time captured is the time in the activity block. These items can be examined in the item report once you run the simulation. Finally, let's add resources. A resource allows us to have multiple activities completed by the same person. Let's say we have one junior detailer who can only do our basic services. We'll make a resource block and name it Junior Detailer, and then set the activity to be Basic Services. That's it. Down at the bottom, you can see we have one junior detailer available through the whole simulation. Next, we'll have the detailers who can work on either basic or comprehensive services. Now that we have two activities, we need to consider the priority of the activities. We want our detailers to work on comprehensive services first, and then work on basic services. Let's set our priority to 1 for comprehensive services and 2 for basic services. We'll still leave this as one resource working throughout the simulation. And finally, we're going to have the senior detailers, and they can work on anything. They can work on basic, comprehensive, or premium, but we want them to work on premium first. Comprehensive is 2, and finally, they can work on basic if they have completed those other tasks. We only have one senior detailer, so we'll leave that number as a 1. So now the final thing we need to do is go back to the activities and ensure the resources we have staffed to those blocks will work independently. If you double-click on an activity block with multiple resources assigned, you'll see a new option where you can select all or one. All means that we need all 3 of these resources to run this activity block for one item, while 1 means that each resource can handle their own item. We can also set a priority if 2 resources are available at the same time. Let's double check our second one. Finally, since our third activity only has 1 resource, it won't have the option to choose between all or 1. All right, so now we should have it. We want to see if we can complete our work in 6 hours, so we're going to run this for 360 minutes. And also note that the number of runs here is set to 10. This means that we can run the simulation 10 times and get summary statistics across all 10 of those runs. As the number of items in our schedule block decreases and premium services are completed, we can see the number of items in other activity blocks increase. You'll notice that we were able to complete this schedule within those 6 hours. Now, let's take a look at the exit block, and we can see the average total lead time across all 10 runs was 40.38 minutes across all items. The second number represents the standard deviation across the 10 runs of those simulations. If we look at the total lead time, we can see a histogram of when those items came in during the first run of our 10 runs. And by looking at the queue length graph, we can see how long it took us to complete all 25 of these jobs. We can see here it's set to 330.92 minutes. Since we've added each of the items individually to the exit block, we can look at their statistics individually. For example, the exterior wash items had a total lead time across the 10 runs of about 29 minutes and a standard deviation of about 1.24. We can also take a look at the total lead time as a histogram to see how long it took the items to arrive at the exit. We can also take a look at the interior cleaning items, which had a total lead time of about 42 minutes and a standard deviation of about 2 minutes across the 10 runs of our simulation. We can also take a look at the activity blocks and see how much of our time was spent in each of the categories of our jobs. We can look at the average block cycle time, or how long items were spending in the block. We can also look at the run and idle times, which are percentages of the simulation where the block was actively working on an item and when it was waiting for an item. If we click this button, we can apply these settings to all of the activity blocks. Finally, let's take a look at the utilization of our resources. How busy was everybody? The junior detailer was busy 93% of the time, the detailer also about 93% of the time, and our senior detailers about 94% of the time. Everybody seems to be working at full capacity throughout the day. Finally, let's take a look at the results of our timer block to know exactly how long each item took in their activity. We can click on the item report available up here and it will open up a list of each item that ran through the simulation. This last column appears because of our timer block, so it's named timer, and contains the recorded times that each item took between those two sections of our process. You can then copy this data to a clipboard, export to a CSV, or export directly to Engine Room for further analysis. So in a nutshell, that's the detail shop scheduling model. But the real value is in what you can experiment with. By modeling different types of work and the skill levels required to perform them, you can see how scheduling decisions affect resource utilization, throughput, and the ability to complete the work you've committed to. And it's not just car detailing. The same pattern shows up in hospitals balancing routine and specialized procedures, software teams assigning work to developers with different skill sets, maintenance organizations scheduling technicians, or any process where some resources are qualified to perform more work than others. From here, you can start to ask real design questions. What mix of jobs should I schedule? Do I have the right mix of junior, regular, and senior staff? What happens if I schedule more high-skill work than my team can support? And where do bottlenecks form when demand and capabilities don't match? Those are the kinds of trade-offs this model is built to explore.
That's the model. Now go experiment. Happy modeling!